Okay, class. Today we're going to go through section 5.1. The name of this section is called probability distribution tables. So we're going to be introducing you to uh, different distributions that are used in real life. And so we need to learn first about the basics of probability distributions. So for a table, it pretty much kind of like a t-table. Like in math, you have you had your x and your y, or when you took college algebra, you had x, f of x. When stats, we use p of x. Right. So let me give you first the definition of what a probability distribution table is. And so let me show you. All right. So a probability distribution table, uh, it's kind of like a histogram. It has the probabilities. So it kind of incorporates what we did in chapter 2 and in chapter 4. Recall in chapter 2 we did probability distribution. We did distribution table, frequency distribution tables, and in chapter 4 we did probabilities. Well, we put them together, and so you have that t-table that I just showed you. So they got two parts for the table, just like the x and y in a regular t-table when you graph. You have the x, and then you have the p of x. Well, the x is called a random variable. So the random variable is a variable typically represented by x that has a single numerical value determined by chance for each outcome of a procedure, right? So the random variable has to be a numerical value, and it has to be a whole number too. So random variables have to be numbers and whole numbers. So it's got to be 0, 1, 2, 3, any whole number will suffice for the x. It can't be a label. It has to be a whole number. And then you have the p of x. The p of x represents the probability distribution. So it is a description that gives the probability for each value of the random variable, and it's often expressed in the format of a table, formula, or a graph. Right? So that's what the p of x value on the chart represents. So let me go back to my table. And so going back, so x is the random variable. So it must, or they must, right? The values must be, all the values in the x have to be all values of x must be whole numbers. Okay, so here's our table. Here's our x values. Notice that they're all whole numbers, 0 through 5. And then you have your p of x. This is your probabilities. They represent the probabilities of each of the random variable x. So this table, we can identify it to represent, let's say that this table represents number, yeah, we'll do number of cups of coffee student drinks per day. Okay. Number of cups of coffee students drinks per day, right? So let's say that we did a survey of our class, and this is our probability. So number of students who drink no coffee in the morning is 0.078 or 0.78%. Students that have to drink 1 cup of coffee per day is 0.259 or 25.9%, 2.346 or 34.6%, 3 cups, 23%, 4 cups, 7.7%, 5 cups, 0.1%. Right. So this table summarizes what maybe the class outcome was in asking students how many cups of coffee they drink. So here's your table. Okay, now you're gonna ask me in a little bit, where did I get these numbers? Well, you're not ready for that. I will show you a formula that gives you these values. Okay, I will show you the formula for it that will construct these or evaluate these values for you. But we're just going to take it for granted. We will be given these values. All right. When we go to section 5.2, I'll show you how they get those numbers. Okay, so what you do with this frequency table is we can't do nothing with it until we make sure that this table is correct. It has to be correct. So there are some requirements in order for this table to be a true probability distribution table. So there are requirements. Requirements that make a table a true probability distribution table. Now we can't do anything with this table. We can't do any analysis on it until we test it. All right, and so there's going to be 2 requirements. All right, so I'm going to write them down, and then I'll translate them what they are in English. All right, so the first rule goes like this. Okay, so that's rule number 1. So what does this say? Remember this symbol, this is the sum. The sum of all your P of X must equal to 1. Now I'm going to put on the side, or approximately equal to 1. It doesn't necessarily have to be exactly at 1. It could be, I could go over 1, like 1.001, that's fine. Or if it's 0.999, that's fine as well. Right, those are good. But if it's way off, like 1.10 or 1.15 something, or 0.97, 0.991, no, it has to be approximately 1. So what you do is you need to make sure that you add this whole entire column of your P of X. This sum has to be 1 or 1.001 or 0.999, right? So let me add it up. Let's see if this table is accurate or correct. So I'm gonna add those 6 P of X numbers: 0.078, 0.259, 0.346 plus 0.230 plus 0.077 plus 0.010. I got 1. That sums up to be 1. Ching. So to summarize, requirement number 1, the sum of all P of X values must approximately equal, there's my little squiggles, equal to 1. That's requirement number 1. All right. Second rule. Okay, now this one's going to look a little bit foreign, but this is how it's written. All right, so it goes. It looks like that. All right, this statement here is called a compound inequality. You don't read this one left to right like you normally do when we read. You don't read it left to right. You don't read it as 0 less than or equal to p of x less than or equal to 1 because you get confused. The way you read this is where, if you look at the p of x, look at where the p of x is at. The p of x is right in the middle. So this statement is saying all of your p of x values, they all must be values between 0 and 1. You have to check each one of those values, all those 6 p of x numbers, to see if they are in between 0 and 1. That's what that means. Each p of x value must be a number between 0 and 1. That's what that means. All right, so if I go through my list, is 0.078 between 0 and 1? Yeah, it's gonna be close to 0. That's correct. Is 0.259 between 0 and 1? Yes. I can summarize this. It'll be easier if you do it like this. These numbers cannot go over 1, and they cannot be negatives. Are any of these numbers above 1? No, they're not above 1. There would be a 1 there or 2, whatever, right? And are any of these numbers negatives? No. So they all pass. So that passes. So that means that this table is good. So you want to make sure when you get a table that it's got to pass both of those rules. If they don't, if one doesn't work and the other one doesn't, then I think that whole thing is incorrect. Either someone typed the numbers wrong or something happened. They both have to pass. You can't, they cannot pass one without the other. So they both have to pass. If it's just one that works, no, it's got to be both. Both have to pass. All right, so in your book, you have some problems that you have to do. So I'm gonna go over here to our page. I think it's 196. 196, I think. Six, almost there. Too far. Now I'm way far. Okay, here we go. 196. All right, you have 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 problems that you can practice on. And the only thing you have to do first, I know it says you have to do more stuff, but for now, you want to make sure that the tables are accurate. All right, so all you have to do for now is to see if those 7, 8, 9, 10, 11, 12, those 7 tables are correct. All right, so let's try number 7. All right, so let's see, number 7. So let's add the p of x numbers first. Do they add up to 1? All right, so let's add them up. 0.031 plus 0.156 plus 0.313 plus 0.313. Hold on, I gotta do it all over again. 0.031 plus 0.156 plus 0.313 plus 0.313 plus 0.156 plus 0.031. I added them up. I got 1. So it passed rule number one, number 7, pass rule number 1. Now I got to see if rule number 2 passes. So I'm looking at all of my P of X numbers. Are any of them above 1? No. Do any of them have negatives? No. So it passes rule 2. So that means 7 is a true probability distribution table. So this one's good. So we're going to label 7 as good. All right. Try number 8. Try number 9. Let's look at number 10. All right. In a Microsoft Instant Messaging survey, respondents were asked to choose the most fun way to flirt, and company table is based on the results. All right. So let's see if this table passes the 2 requirements. Now this is a tricky one. All right. So point, I'm gonna add them up. Well, actually, you know what? We don't even have to add it up. Even before we even test the 2 requirements. What's wrong with it? I can tell you right now that this table is not correct. It's wrong. What's wrong with table number 10? Well, we cannot even, it's not going to work. I mean, I add them up and it comes out to 1 and they're all still negatives, but there's something else that makes it not be a true probability distribution table. That's right. If you notice, my X column are not whole numbers. They are labels. Right there, that tells you that this table is wrong. So this is a no. Totally no. So besides the requirements of adding them and then making sure that all your P of X numbers are correct, you want to make sure that your X values are whole numbers before you even do that. So 10 is a no. Try 11. Try 12. What's wrong with 13? Same thing for 13. I'm not going to even bother adding and checking all your P of X. My X column are incorrect. All right. And then try the other ones. That's all you have to do. All right. Just test the table. Now, the ones that pass the requirements, the ones that are true probability distribution tables, we can go further and do some analysis. So let me put that in my notes. Hold on, let me share my screen. So for the probability distribution tables, that pass the requirements, we can now perform some statistical calculations. Right. So we can do 3 things. We can find the mean, right? We can find the standard deviation and the variance. Okay, so you recall the symbols for mean. Now we're using the universal one, the population. So as you recall, mean, the symbol for mean is mu. The population standard deviation symbol is the O, the curly O, and the variance is the O squared. All right, so the formulas that we're going to use are going to be a little bit kind of rough, but that's how they work. So I got to show you how they work. All right, so here's the formula for the mean. So the mean formula, mu, All right, equals the sum of x times p of x. Right, that's the formula for the mean. Okay, so let's I'll let you copy it. So the way it works is it's kind of like PIMDOS. You have to work the inside first. So you're going to have to multiply each of your random variables times its p of x. You have to multiply. So you're going to have to create a column and multiply x times p of x and create a column. And then at the end, you sum all that column down and that'll give you your mean. Right. So I'm going to do number 7 as an example because 7 worked, I believe. 7 was the there's the 7, the genetic disorder. All right, so let me do number 7 with y'all, and we're going to find the mean. So I'm writing down my table, and so I'm gonna create this one table, and I'm gonna do all of it. I'm gonna show you all the work so that way you all can find your your mean, your standard deviation, and your variance. 0, 1, 2, 3, 4, 5. P of x numbers are 0.031. Notice as I'm writing, I'm copying down the table. If you notice that this table is bell-shaped. It is a normal curve. Do you see it? Do you see why it is a normal bell-shaped curve? Yeah, because if you look at the numbers, see they're symmetrical. The ends are the same, second to the ends are the same, and then the middle is the same. Look, it's a bell shape. All right, so I wrote down my table, and now I'm gonna find the mean. All right, so here's my formula. Here's my table. All right, so you are going to have to create a column. So I'm going to create a new column, right? And I'm going to multiply each of my x with the p of x. I'm multiplying x times p of x. So I'm going to multiply 0 times that number and put my answer here. So 0 times anything is 0. 1 times 0.156 is 0.156. 2 times 0.313 is 0.626. 3 times 0.313 is 0.939. 4 times 0.156 is 4, 22. I believe that's 624. And 5 times 0.031 is 0.155. You can double check for me just to be certain. Yeah, I think I got it. All right, so this column represents that inner part. And now I can do the end, which tells me to do the sum. So I'm going to add that whole column, and that'll give me the mean. So I'm gonna add all those 6 numbers. 0 plus 0.156 plus 0.626 plus 0.939, 0.64, 2.5. Okay, 2.5. So whatever the sum you get, you're gonna write all the numbers. even if it's a lot of decimals behind it, you're gonna leave them all there for now. We're gonna find first, we're gonna find all three values. And then at the very end, after we get the last one, then I'll tell you the rounding rules for it. So whatever that number is, you're gonna leave it as it is for now. So my number for my mean is 2.5. Okay. All right, so that's the mean. Okay, now I got to show you how to find the standard deviation. Standard deviation, that is the curly O. Now this is going to be a little bit hard on your eyes, right? This is going to be a little challenging. So here it goes. So you have this symbol, and then within the symbol, which is the square root, right? You're going to do the sum of x squared times p of x minus mu squared. All right, so let me show you the formula where I'm getting that from. If you go to your textbook, all of the formulas should be listed in the book somewhere. Where is it at? Oh, pass it. There it is. There it is. There's the formula for the mean. And then here's the formula for the standard deviation. Okay, it's right there. All right, so yeah, just like I had written it right. Okay, so let's what is that far? Anyways, I don't know where I went. I think this is 5, way off. Way. I don't know how I got to 5. Okay. So let's go back to our problem, and we're gonna add on to our table. So all right, so here's our formula. Here's our formula. All right, I'm gonna go back to my table. Okay, and I'm gonna tack on. Okay, so here's my formula. Here's my table. Right there. Okay, now there's the square root. We're going to do the square root at the very end. Again, you're doing PEMDAS. So what's the rule for PEMDAS? You got to do the brackets first. So I have to do this part here. Right. So I have to multiply x squared times p of x. Well, I have the p of x, but I don't have x squared. So what you're going to have to do is you're going to have to make a column in front of the x and label it as x squared. And so what you're going to do is you're going to square each of these values, and you're going to put the results here, right? Square. So you're going to do 0 squared, that's 0. 1 squared raised to the second, that's 1. 2 to the second is 4. 3 to the second is 9. 4 to the second is 16. 5 to the second is 25. Now I have my x squared. Now I have to multiply that x squared times my p of x. So I have to multiply that column with this column. And I have to make a new column. So I'm going to, let me add on. And so I want to do x squared times my P of X. So I want to multiply, I need to cover it up. I need to multiply those two columns, this column with that column. So I'm gonna do row by row. So I gotta multiply 0 times 0.031. That's 0. 1 times 0.156 is 0.156. Now the numbers are gonna get a little bit big, so I'm gonna have to use my calculator. So I'm gonna multiply 4 times 0.313, 1.252, 9 times 0.313, 2.817. Yeah, you don't round. You're not going to round to the very end. Next one, 16 times 0.156, 2.496, and 25 times 0.031, 0.775. Again, you're multiplying your X square values with its P of X, and you're putting the answers here. So I did this part right there. Right, and again, like we did with the mean, we did this part. Now I got to do the sum. So I have to add. I'm completing that part. I need to add that column, and that'll give me this piece inside of the square root. Right, so I'm gonna add this column. I'm gonna add these numbers: 0 plus 0.156 plus 1.252, 2.817, 2.496, 0.775. Gives me 7.496. So that's what this number is. This number is 7.496. And then I got to do minus. All right, now the mu. We already computed mu. That was the red. What do I have to do with the red? Whatever this number is, that's why I tell you don't round it to the very end. So if you have more digits than 5 at the end, you gotta square it. So we're gonna get this number and we're gonna write it here and we're gonna square it. We're gonna raise it to the second power. Just like that. All right. And then you can either type the whole expression inside the square root first. It doesn't matter. I'm gonna do it in pieces. So I'm gonna do 7.49496, sorry, minus, I'm gonna go ahead and square 2.5. So I'm gonna do 2.5 hat the second 6.25. Right, and now I'm going to subtract inside. So 7.496 minus 6.25. I get square root of 1.246. And now I got to take the square root of that number. So square root, as you recall, square root usually I'll have to hit the second key, the green. Second, and my square root is right here next to it's green, so it's square root. My square root, and I type in 1.246. And I have to write down all the digits that appear on my calculator. So I got 1.1162433701. That's what I've got on my calculator. So that's my unofficial standard deviation. So it goes back to your creation of your table. You had first, when we found the mean, you just multiplied those two to get the purple, right? Those two. When you do the standard deviation, you have to add an extra column in front. You're squaring your x's, right? And then you're multiplying each of your new values of x squared, and you're multiplying them to the p of x to get these numbers. It takes practice. You got to practice. Right? That's how you get that. All right, and so that's how you get the standard deviation. Right. So yeah, the standard deviation is the more difficult, challenging formula that you're gonna have to use and find, evaluate than the mean. Okay, now that's how you find the standard deviation. Now I got to show you all how to find the variance. Variance, as you recall, symbol for that is sigma squared. All right, so here's the formula. So the formula goes like this. Sum x squared times p of x minus mu squared. So how is this formula different from the standard deviation? That's right. The variance does not have this square root surrounding the expression inside, right? So there is no square root. So when you compute the variance, you already completed it. You already computed it when you did the standard deviation. That variance is going to be the number just before you took the square root. So the number that's inside the square root is going to be your variance. So that number right there, that is your variance. So my variance, I didn't have to do any work because I already did it, is 1.246. Simple. The standard deviation does both formulas. It computes the standard deviation and it also computes the variance. Just that the variance does it before you take the square root. Simple. All right, so now I got my variance, I got my standard deviation, I got my mean. So let me write them all down. So my mean ended up being 2.5. My standard deviation was 1.116243701. And my variance was 1.246. And now you're ready to round. All right, so the rounding rules. After you complete all three values, the mean, standard deviation, and the variance, you are going to round to the tenths. Now round all answers to the tenths. So that one's done. 2.5. Right. This one's going to be 1.1. This one's going to equal to 1.2. And some of them you don't have to round like the mean, but the other ones you're going to have to round them to the tenths. So that's the rule for rounding your mean, standard deviation, variance when you're dealing with probability distribution tables. Now, why do we round to the tenths? Well, because your x values, your random variables, were whole numbers. Of course, we remember, you always round one place further back than how your data is given. Well, in our case, we're going to use as our guide the x variables. So they're whole numbers, and these are tenths. All right, so I think there's when we went through all the tables, I believe there were going to be from the 7 tables that you have to practice. I think there's 2 of them or 3 of them that were that they do work, that they fulfill the requirements. We already did 1, so there's going to be another one you're going to have to do. So you'll have to find the mean standard deviation variance from that. All right, so once you know this, you know how to compute that. It's a pain in the butt, I know. It's a pain in the butt. we can determine if events are usual, unusual. As you recall, remember our range rule of thumb, usual, unusual. Well, we can determine, we can compute the minimum, usual, and max usual to determine if an event is usual or unusual. Right. So as you recall, our max usual was computed by using this formula. Mu plus 2 times the standard deviation and the minimum usual was computed by mu minus 2 times the standard deviation. Now, in order for us to do that, of course, you have to compute the mean and standard deviation, right? That's why we had to do it. So based on our result from our table, I can plug in these numbers into my formula. So as you recall, mean was mu, standard deviation was sigma, and variance was, I should have written standard deviation with the O, right? Instead of words. My bad. I have to be consistent, right? If I use mu, I have to use sigma. Okay, so let's plug it in. So my mean was 2.5. There's my mean, 2.5 plus 2 times my standard deviation was 1.1. The other formula is the same, except instead of a plus, I'm going to put a minus. So this should be 2.5 minus 2 times 1.1. And so we get, plug it into my calculator, 2.5 plus 2 times 1.1, 4.7. And the other one's going to be 0.3. There's my max, there's my minimum, right? So the table that we were talking about had to deal with, I believe it's disorders among men. Gene disorders? I don't remember, I had to look. Genetic disorders among males. And the random variable X is the number of children among the 5 who inherit the X-linked genetic disorder. All right, so X represents the number of children. So if you conduct the study and you find that 4 children have that genetic disorder, would that be usual or unusual? 4. Well, as you recall, the number, if there's a number that they gave you and it falls in between, that means it's usual. So 4 would fall in between, so that would be usual. All right, so let's say you do another study and you end up seeing that there were six children. Well, that would be unusual because it exceeds the max. What would be the what would it be if would it be usual and usual if you found there were no children with the disorder? Well, that exceeds below, right? So that would be unusual. Anything in between is usual. Anything outside is unusual. Now, the thing is, if you use these formulas, right, just letting you know, if you're going to use these formulas, you need to find the mean and the standard deviation from the table. And you know how long that took. Well, it can be done. You can do it. So what's the bad? The bad thing about this, I guess you can say the cons, cons for using this method to see if a value is usual or unusual is that you must find the mean, standard deviation, and variance to compute. It's tedious, very tedious. That's the cons for using this method. Right now, there is an alternative to finding whether things are usual and unusual instead of having to do this concept. And I will show you. But this is another way, alternative way to identify usual or unusual events. Okay. All right, so let me show you the alternative. All right, so in the book, it is, let me see what slow to do that. In the book, it is, and it's going to look kind of, again, it's going to be Greek to you all. Never seen it before, and that's good. It's on page 192, and it's right here. Identifying significant results with probabilities. All right, so this is how you find it. So let's write down the bullets. All right. Okay, so for the bullets, the first one, it says significantly high number of successes. Okay, just write that down. And you're going to write the formula. There is a formula right there. Okay, so you're going to write probability, parentheses, X or more, close parentheses, is less than or equal to 0.05. Okay, that's first formula. All right, second bullet, you're going to write down significantly low number of successes. You're going to write that down. Significantly low number of successes. And you're going to write down the formula. This one. P parentheses X or fewer is less than or equal to 0.05. Right, so I'm gonna explain to you how this procedure works. The only thing you're gonna have to do is pretty much just add and compare. That's all you do. You're gonna add and compare. So add and compare. So I want you to look at so what you're gonna do is you're gonna go to the table and you're gonna add and find this part. And or you're gonna add the columns and find this. And you're gonna compare that value that you add has to be a number that's smaller than 0.05. So think of it in terms of money. This value, these values in the left of the formulas, both of them, they have to be a number that's smaller than a nickel. Must be smaller than a nickel. This piece must be smaller than a nickel. Hope I spelled nickel right. This too, right? Must be smaller than a nickel. Nickel, I don't know how to spell nickel. Right, so here's the thing. If it's true that it is smaller than a nickel, then let's go back. It would be unusual. If it's false, then we say that it is usual. I hope I got them right. I think so. Let's see, what did it say in the book? Okay, all right, so let me show you an example. So coming back to let's go back to the book. And let's see, we're going to do, I'm going to show you the setup. Right, before we show you how to use the formula, we're going to do an example so you can understand the concepts. Okay, now here is a table on genetics. I know a lot of you are going into the medical field and you're going to be going through you have to take biology, right? You have to take biology and you're going to have to go through genetics. That's how it works. All right, so in genetics, we're going to do number 15. Okay, so this table here, so let me tell you the background story. So they were observing 8 couples that were in the hospital. They're getting ready to give birth to babies, right? And so they're observing the 8 couples. All right. So they wanted to know, they were up there, and then when they had the babies, they were observing the number of girls that were born among the couples. And so they calculated the probabilities of the number of girls. So within those 8 couples, what was the probability that none of the couples have girls? Well, it comes to find out it was 0.004. What if one of the 8 had a girl? It would be 0.031. 2, 0.109. 3 of the couples have a girl, it's 0.219. 4 is 0.273. 5 is 0.219. 6 is 0.109. 7 is 0.031. All 8 have girls is 0.004. Yes, that's correct. It is a bell-shaped curve. Notice where the peak is. It's at 4. Well, yeah, the probability of a girl is 50-50. So if you have 8 couples, the odds of half of them have girls is high. That's why it's peaks at 2.273. All right, now let's look at this table here, right? And suppose I asked you from this table, based on that table, what is the probability? And you gotta be aware of the terms that I'm using, okay? The wording. What's the probability that exactly 3 girls are born among the 8 couples? Exactly 3. What would the value be at exactly 3? Right? So to figure out exactly 3, you go to 3, right? You go to 3 and you look at the P of X. And so my P of X is 0.219. That's it. Your probability is 0.29. That's how easy it is. Bam. All right, do another one. What's the probability of exactly that there are exactly 7 girls among the 8 couples? Right, so you go to your table, you go to 7, and then you write down the probability, which is 0.031. There you go. That's it. So when it says exactly, you go to that specific X value and you read the P of X value that corresponds to it. And that's your probability for exactly, right? You go to that X value, reference it to your P of X, that's your probability. All right, now, what if the problem read, find the probability of 5 or more? 5 or more. All right, so 5 or more. What does 5 or more mean? Well, it's starting at 5. You're going to count upward, right? So what are you gonna do with the values of the P of X when it's 5 or more? So you're gonna add the value of the 5.219. You're gonna add the value of the 6. You're gonna add these numbers. Am I right? You add all those numbers, these, not the X, but you're gonna add those 3 numbers, and that'll give you the probability of 5 or more. So I'm gonna add 0.219 plus 0.109 plus 0.031 plus 0.004. Gives me 0.363. I'm gonna double check, is that correct? 219, 109, 103, 031. And yep, that's correct. Okay, so that's how you do it. All right, so let me show you my work. Add 5 up. From 5 up. Add from 5 up, right? Add from 5 up. from 5 up. Okay. What about if I ask you find the probability of 4 or fewer? Right, 4 or fewer, right? So let's go to my table. 4 or fewer. So 4 or fewer. So from 4, I gotta add 4 down. So I'm starting at 4. I gotta add 0.7273, 0.219, 109, 0.031, 0.04. So it's from 4, add from 4 down. It looks like up. What else? So you add those 5 numbers, 0.004 plus 0.031 plus 0.109 plus 0.219 plus 0.7373. Oh, I got error. Why did I get an error? No, that's why. Okay, so I'm gonna have to add them again. 0.004 plus 0.031 plus 0.109 plus 0.219 0.273 is 0.636. These blue on the right, I'm adding them because it says 4 or fewer. 4 or fewer. That's what that says. Right? So let's recall. Exactly means you go to that specific value, look at your P of X. That's your answer. Exactly. 5 or more. You're going to go to 5 and you're going to go from 5 up, add all your P of X values. That's how we're calculating that number. If it says 4 or fewer, you go to that value and you go down 4 or fewer, you go 4 less. You add all those P of X, and that's how you calculate that. Okay, so you have to keep an eye on the wording. Right now, if I want to do the alternative to finding usual and unusual, right? If I can find the page where I left it, I had it here somewhere. Let's see if I can find it. There it is. Right? It's got to say X or more, or it's got to say X or fewer in order for you to use the alternative. Right? You don't want to do that and find the mean standard deviation, right? So you want to do the alternative shortcut. So you look for these specifics. It's got to say X or more, X or fewer. If it says exactly, you cannot use the alternatives. You cannot. It's got to specifically say those two terms, either or. So either you add from that value up or from that value down, right? And it'll tell you significantly high, significantly low. All right, so let's go and do the problems in the book. And we're going to use alternatives. Okay, so we're going to do number 18. I know 18 is not part of your homework, but I'm going to apply the shortcut to it. All right, so let's do 18. So 18 says, all right, 18, using the table with the girls, A says, find the probability of getting exactly 7 girls. All right, so it says exactly, right? It says exactly. So I go to 7 and I get the values. So my answer is 0.031. Boom, that's it. Okay, what does B say? B says find the probability of getting 7 or more. 7 or more. What does that mean? I gotta go 7 or more. So 7, it goes up to 8. That's the max. So I'm gonna add 0.31, 0.004. That gives me 0.035. All right. And then C says, which probability is relevant for determining whether 7 is a significantly high number of girls in 10 births? All right, so if I'm going to use a shortcut, which of these two will give me my answer, A or B? The exactly or the fewer, or the more, sorry. The exactly or the 7 or more. All right, we're gonna use my alternatives, right? So does it say exactly on there or few? More, there you go. Yeah, you're right. It said a high number. So I'm going to use the extra more. So I already did that. So I'm going to use that formula. So probability of 7 or more. I'm writing down the formula. Okay, there's my formula. Okay, there's my formula. And now I'm going to get my value right there. This is this value right there. And I want to see if this is true or false. Is 0.035 smaller than a nickel? I mean, you can round it off. That's 4 cents. Is 4 cents smaller than 5 cents? Yes, it's true. So we said that it is unusual. It is unusual. And there you go. That's it. Okay, we can do another one. We can do 19. Okay, 19, similar. All right, answer the question based on that table. All right, so 19 set A says, find the probability based on that table, find the probability of getting exactly 6 girls. Exactly 6 girls. All right, so I have to go to my table and go to 6. And I can highlight it. 0.109. 0.109 is 19A. 19B says find the probability of getting 6 or more. 6 or more. How do I do 6 or more? Do I add from 6 down or 6 up? That's right, 6 up. So I got to add 0.109, 0.031, and 0.004. .144. And then C and then C says which is more relevant in determining whether 6 or more is unusual? It has to be B because the formula for the alternative had to say the word or more or fewer. So it's got to be parts. Part B. I forgot that's part B. Part B, and then answering the I didn't label the other one. That was part B. Part B. And then C says is, what did they say, is 6 or fewer or 6 or more? 19. Is 6 a significantly high number? Is it unusual? So we're going to use a shortcut. So 6 or more is that value that we ended up getting a number that's smaller than a nickel. Well, this is 0.144. Is that number smaller than a nickel? No, that's false. It is usual. False as usual. So you have options. You can do the shortcut, or you guys can find the mean, standard deviation variance, and you can find whether or not it's usual or unusual, 6 or more.